Hello and welcome everybody to my presentation on PromotePL, a round-trip engineering process model for adopting and evolving product lines. This is a collaborative work with Vardar Mahmoud and Thorsten Berger, both from University of Gothenburg Chalmers in Gothenburg, Sweden, and myself from University of Magdeburg in Germany. To get started, I think we all know those typical product engineering process models where you basically start always with domain engineering, where you have some activities for engineering a product line, so the platform, where you have something like product management as a management activity. Then you have domain requirements engineering, where you capture the requirements that are part of the domain. Then you actually try to design the domain, for example, based on feature model. Then you have a domain implementation, so the actual code base that you use for your product line. And then you also do domain testing, so you try to test this platform before you instantiate any variant in order to ensure that your product line platform actually works properly. And those models basically originated some decades ago and have been proposed, for example, by Pohl et al. And Northrop and Clemens. And they are all pretty similar with some minor changes, minor updates, but they all go into this direction. And if you have this platform according to those models, you basically then continue with application engineering. And in application engineering, you somehow mirror some of the domain activities. That is, you do requirements engineering for the specific product you want to derive. You somehow customize the design according to the needs of this product to somehow fulfill the requirements that are tailored to a specific customer. Then you implement, for example, product-specific parts, and then you test the application before shipping and selling it to the customer. However, as said, those process models are rather old, and they are most likely, or they are not anymore in line with current practices of how product line engineering happens in practice. That is mainly due to the fact that they are not updated with advances in research and with modern technologies in software engineering. So just to give some examples that we found in the literature and that we experienced in practice and collaborations, the strict separation that exists in those models between domain and application engineering does not really reflect current practices. In practice, what we found is that there are mixed teams that do domain and application engineering at the same time, that there are some more distinctions between different teams, but that the overall involvement is a bit more strict. For example, that a feature is defined in an application, is then refined, tested, and then just submitted to the platform. There it's just reviewed and propagated back if something needs to be fixed. So this is not that strict separation between who does implementation on the platform and who does implementation on the product. And similarly, going in the same direction, basically those models assume that evolution only happens on the platform, whereas, as just said, we found that evolution also happens on individual variants that are later integrated into the platform. And finally, just as a third point, all of those process models focus basically on the proactive adoption, so platform first, then products, whereas we've found and literature shows that especially extractive adoption, where you have a set of products, is far more common and should be somehow resembled in those process models, but it actually isn't so much. Some assume it or specify it in some details, but the process models themselves don't actually represent that. So we thought that it would be really necessary to construct a process model that aligns with modern product line engineering and software engineering practices. And for that, we defined 3 research objectives. The first one was to elicit empirical data on those modern product line engineering practices and synthesize, as a second objective, a concrete process model for product line engineering. And finally, we aim to understand the adaptations and modern practices that are established in software engineering and align or enable or are represented in the process models that we derived. I will mainly focus in this talk on the second objective of representing the model itself. So to consider the data we elicited, we basically had 33 different publications as data sources. And to identify those publications, we defined some inclusion-exclusion criteria, like they should define concrete activities that have been reported in practice in a specific order. However, we also involved those initial process models I just showed, and for that we used 5 publications that are rather old. Otherwise, we focused on publications that have been published in the last 5 years, so really trying to incorporate modern practices. And as a first step to select those papers, every author basically proposed a set of potential relevant papers, and we checked those due to our criteria. And then we also conducted a systematic literature review of the last 5 instances of 13 different venues, including SPLC, ICSE, VAMOS, and so on. And we also involved our own experiences from collaborations with different companies, for example, Axis, ABB, or Grundfos. And we used all this data and all the information we gained to basically construct our model by first extracting the concrete instances that have been mentioned in the papers in their partial orders. So, for example, we found over 150 different over 150 activities to be mentioned in some partial orders. So, for example, we first do feature modeling, then you derive the product line architecture, then you derive a variant on a high level. And we consolidated those activities and found that there are basically 99 distinct activities. And because some of them have been rarely mentioned or even mentioned only once, we basically compared those activities and the partial orders in which they are, try to identify similarities, redundancies, and removed some that are have been mentioned only once or that were really specific to some domains. And that way we came up with the first instance of the model, and basically I, as the first author, presented that model to the last author of this paper and explained every design decision and where the decision stems from, what data I used, and all of that I basically explained. And that way we refined the model and tried to verify that it's properly designed. And in the end, we called our model PromotePL, which stands for Process Model for Round-Trip Engineering of Product Lines. So to give you a brief overview about the details of the model, this is what it looks like on the really detailed level. And I will not go into too much detail in this presentation on this model, but you can see that it's involving a lot of different activities. It has some decision nodes, it has different starting points. And with those gray arrows, we basically illustrate different patterns like adoption patterns, evolution patterns, and so on that are part of the process. And to give a more abstract view on this process model, we basically took those patterns and came up with this really abstract representation that doesn't give all the details of the process model, but gives a high level understanding and a good abstraction that can be used to describe the model on a more coarse-grained level. And this basically separates adoption activities and evolution activities, in contrast to, as previous process models do, application and domain engineering, and basically involves 4 major nodes. Those are the integrated platform itself, so the product line platform, from which we can derive variants. Those variants we can basically evolve into new versions. And we also have a set of planned, for example, for extractive adoption, or existing variants, for example, for extractive adoption, planned for proactive adoption. So to give a bit more insight into the details, as said, the first change we did was basically that we changed the primary decomposition from domain and application engineering towards adoption evolution. We found that in practice, this is how practitioners want to handle and understand product line engineering. They're not so much concerned about strictly separating domain and application engineering into different teams, but they're more concerned about how to adopt the product line, how to adopt variants into the product line, and how to evolve the product line. And this evolution basically also based on different patterns. A second change that we employed is basically that we involved more management activities. Those are not represented in this really abstract graph, only in the detailed one. However, as said previously, there have been like high-level management activities, 1 or 2 in the process models, and we found that in practice and in the reports, far more are mentioned, for example, for the budgeting of the product line. And because these have been mentioned repeatedly and sometimes emphasized as really the challenging activities, we incorporate them in more detail into our process model. A third change we employed is basically that we include now all 3 adoption strategies. And here you can see basically in the top, it's a proactive and extractive adoption. That depends on whether we are talking about planned or existing variants. And in the middle, that is basically representing reactive adoption. So you have, for example, an existing variant that you derive, and then you evolve that variant, and at some point you try to incorporate new variants into that variant, and that way you at some point arrive at the integrated platform. And this is really important because practice just shows that extractive adoption is far more common, and mostly it's done in some reactive manner. So you integrate variants into each other, and you do not necessarily start with a well-defined initial set of product variants you want to have and can start really proactively with your product line engineering. That's just not happening in practice. Fourth, we represent different evolution strategies, particularly variant-based platform evolution, where you have a derived variant that you evolve, and then you have some existing variant that you want to reintegrate into the platform. And this can be done mainly by two patterns. The first one is that you really want to integrate the whole variant just by integrating it, or that you want to do asset-based propagation, basically. And that is something we found in practice, that basically development teams that evolve a specific product can propose features to the platform, and for that they develop the feature already on the platform. So basically they copy the whole platform, develop the feature for this new product that they customize, and they basically do all the evolution on a clone of the platform, and then they can propose individual features based on the assets back to the platform, and the platform teams only verify whether this is valid and whether there are some errors to be fixed, and this is how the evolution actually happens. And lastly, domain application engineering are not represented here anymore. However, they are still incorporated, obviously, and they're cross-cutting, right? The integrated platform is still domain engineering, and instantiating a concrete variant is still application engineering. However, they are more tangled here in the process, and they are not the primary decomposition anymore. So just to give you a rough overview about what PromotePL actually offers, it is just a concretely updated process model that aligns to modern practices. It separates more into adoption and evolution patterns, and it incorporates different patterns of adoption and evolution. In contrast to some previous models, it's based on empirical evidence and industrial practice, and it's based on consolidated orders of product line activities. It has a coarse and a fine-grained representation that can help to communicate to different audience, and it connects product line engineering also to some modern software engineering practices, which has not been part of this talk actually. Thank you very much for your attention.